All right, here are quiz 1 solutions. Physics, we're throwing a ball up, and its height after x seconds is given by this equation. It's not the right equation, in case you were wondering. Maybe somewhere it is, not on Earth anyways. But I wanted the numbers to work out relatively nicely. Anyways, we want to find the average speed from time 2 to time 3. So 2 seconds after I throw the ball to 3 seconds after I throw the ball. Average speed kind of hints that you should use your average rate of change formula, which is just the difference in the two y coordinates divided by the difference in the two x coordinates. We're given the two x coordinates, that's nice. We're not given the two y coordinates, but we can figure them out. Y2 is just the y coordinate when x equals 3. It's just the y coordinate at x2. What I'm trying to say is it's just f of 3. F of x is this mess, so f of 3 is negative 2 times 3 squared plus 20 times 3 plus 6. 9 times negative 2 is 18 negative plus 6. I can do this. Negative 18 plus 60 is 42. 42 plus 6 is 48. I think that's right. And then y1 is just the y coordinate corresponding with x1. x1 is 2, so it's just f of 2, which is negative 2 times 2 squared. 20 times 2 plus 6. So let's see, 2 squared is 4 times negative 2 is negative 8. Negative 8 plus 40 is 32. 32 plus 6 is 38. Okay, now that I have the two y coordinates, I can just plug them up into this formula. Y2, 48, minus y1, 38, divided by x2. Did I do that right? Y2 is 48. Okay, I did that right. Divided by 3 minus 2, x2 minus x1, 10 over 1. In other words, 10. The average speed of the ball from time 2 to time 3 is 10. It's still going up. Average speed is 10 meters per second if you really want, or feet per second. Did I even tell you the units? I didn't even tell you the units. So something's per second. But I don't care about units. Just give me 10 and I'm happy. Find the average speed of the ball, 10. It's a math class, not a physics class. Find the average speed of the ball from 2 to 2.01. All right, this is a little bit overkill. It's the exact same as the last one. The only thing that changes, I guess I shouldn't say anything changes if I said it's the exact same. It's not the exact same, it's very similar. Here my two x coordinates were 2 and 3. Here they're 2 and 2.01. So x2 is 2.01, x1 is 2. Y2, I'm going to go ahead and use a calculator for that. So I got negative 2 times 2.01 squared. That for a second to answer a question. So what was I doing? I want to figure out y2, which is just changing all the x's here into 2.01. So negative 2 times 2.01 squared plus 20 times 2.01 plus 6, I believe, plus 6. And I get this number, 38.1198. Oh man, busy man. And y1 I already figured out was 38. Guess I should go answer that. Hold on again. Alright, back again. So we plugged in these numbers that we got. If you do the calculations, 38.1198 minus 38 is just 0.1198. And 2.01 minus 2 is just 0.01. So what we get for our answer is 11.98. So the average speed of the ball between these two times, 11.98. So last question, either the easiest question on this quiz or the hardest one. Estimate the average, okay, this is the wrong question. Estimate the speed. Maybe I'll put instantaneous in there to make it more clear, of the ball at x equals 2. We don't know how to calculate the speed of the ball at x equals 2. All we can do is estimate it. The way you estimate it is, well, it's very similar to the average speed when the time is close to 2. In other words, it's a number very close to this 11.98. Let's say it's about 12. I don't know what else to say about that. Second question. You got a function, and it wants you to sketch the secant line from x1 equals -6 to x2 equals -1. So that looks like from this point right here to this point right here. I want you to sketch the secant line. All that's saying is connect those two dots with the straight line. Easier said than done. It's hard to draw straight lines on my computer. Try a third time and just call it good enough, even if it's not very straight. That's pretty good. Sketch the secant line. Done. Calculate its slope. Sure, to calculate the slope of the secant line, you use your average rate of change formula. It's just y2 minus y1 over x2 minus x1. If I call this point right here x1, y1, it looks like the x coordinate is -6. And the y coordinate is -1. And then I can call this point right here x2, y2. Its x coordinate looks like it's -1. And its y coordinate looks like it's -6. Oh, that's kind of tricky. I guess that's fine. -6 minus -1. That's the same as -6 plus 1, which is -5. -1 minus -6 is the same as -1 plus 6, which is 5. -5 divided by 5 is just -1, which is about what this looks like, right? It's negative and roughly diagonal. So it's got a slope of -1. All right, now I want you to come down here and sketch the tangent line at x1 equals -2. So -2, they're talking about this point right here. I want you to sketch the line tangent to the curve at this point. So that's kind of the line that just barely touches right here. That's pretty good. It looks something like this. Maybe I'll make it a little thicker so that you can't tell that I kind of missed it. This thing in blue right here is my tangent line. Sketch the tangent line, done. Estimate its slope. I don't know if I was looking at this thing. It's definitely got to be a positive number. It looks in my picture like it's about 2. Right? It goes up by about 2 every time it goes over by 1. So I don't know, roughly 2. Anything from, I don't know, 1 to 4 is fine. Just make sure you put in a positive number and, show me that you know what you're talking about. As long as it matches your picture. And that's it. That's the end of the quiz. So really what we're doing is we're kind of getting the idea of secant lines and tangent lines. Up here, we calculated secant lines and used one specific secant line to estimate the tangent line. Down here, we did it more graphically, less calculations. We drew the secant line and we drew the tangent line. And then we ballparked their slope since we were there. That's the end of this quiz. I guess I'll just stop the video here.